So problem 17, all the numbers 2, 3, 4, 5, 6, and 7 are assigned to the 6 faces of a cube, one number to each face. For each of the 8 vertices of the cube, a product of 3 numbers is computed, where the 3 numbers are the numbers assigned to 3 faces that include that vertex. What is the greatest possible value of the sum of these 8 products? So I'm just going to draw out a diagram. A, B, C, D, E, and F. I hope it's somewhat figure outable which letters correspond to which faces. And yeah, so the values at each of the vertices are going to end up being like, use a different color. That's like ABC. That's like BCD. This is like BAE. This is like BEF. This is like ECD. This is like ECF. This is EAC. And this is AEC. So there's something you might have noticed here, and it's that the values at the top 4 vertices are very similar structurally to the values at the bottom of the vertices. Like the sum of the things on top is B times AC plus CD plus CF plus AF. I think, yeah. Plus AF. And the values at the bottom are E times, AC plus CD plus CF plus AF. What a coincidence. And like this makes sense because the values at these 2 vertices, for example, the values at like those 2 vertices, one of them is like those 2 vertices are share 2 faces which they're adjacent to, and then the other 2 are B and E. So it's going to be like one of them is going to be B times DF, and the other one is going to be E times DF. So that means that the total sum is B plus E times AC plus CD plus CF plus AF. And you can actually do that again. This thing here also factors. Why? It's like very similar logic. It's like you can do a similar pairing up thing, but also like algebraically, this is going to end up being A plus D times C plus F. You can verify that by expansion. Also because like the 4 faces this is not, I don't know if this diagram works. Okay, A, C, D, and F. Like, okay, so the vertices here versus the vertice here. This one has an F times A, where this one's an F times B, D. This one, and then in a similar way, the vertice there will be an A times C, and whereas this one will be DC. And so yeah, once again, it'll be A plus D times C plus F. And so yeah, actually the total sum of the values of these 8 products is B plus E times A plus D times C plus F. And normally, how do you maximize products? Well, when you want to maximize the products, when you know the sum. So yeah, we know that like A plus B plus C plus D plus E plus F is going to be 2 plus 3 plus 4 plus 5 plus 6 plus 7. When you want to maximize the product, you usually make the terms as close to each other as possible, which means that ideally we want to have a 9, 9, and 9, and we can actually achieve that by doing this, which gives a value of 729. Yay.